Hey guys. So, as per usual, I'm going to give you a little bit of time to start class today to make sure that you've completed this homework assignment so that when you are checking your answers, you are actually already have answers on your paper. And we are truly checking and not just looking up at the board and saying, "Oh, yeah, that looks like the answer." So, if you could please pause the video and make sure that most of the students have had time to finish this before we check our answers. Once the majority of the class is ready, go ahead and restart the video so we can see how you did. All right, guys, let's see how you did. So on the first two problems, we actually did something very similar to this in our previous class session, where we said that the order that you multiply in doesn't matter. So numbers 10 and 11 are both going to have the same answer, which is n to the power of 32. For number 14, I got w to the power of -7. Now on numbers 16 and 17, those are both two-step problems. We practiced this in class earlier this week. We said that your first step is going to be multiplying, and your second step is going to be adding. Now, on number 16, you got to be really careful because this d right here does have an exponent of 1. And so we want to remember that there's an exponent of 1, and then we're going to add that with whatever -2 times -9 is. And so I got for my final answer on number 16, d to the 19th. So we did -2 times -9, which is +18, and then we added a 1 to it. Very similarly, on number 20, we're going to do our multiplying first. So we circle these two, and we circle these two, and we multiply each one together. And then we take those answers and we add them. And so my final answer for number 20 is t to the -14. All right, those last three problems are fill in the blank. So we're trying to figure out b squared to what power will turn into b to the 8th. And since it's a multiplying problem, it's really asking us 2 times what is 8? And the answer is 2 times 4. So 4 is what goes in that box. Now, numbers 45 and 46 were a little bit tricky. So again, whatever is in the box is going to end up being multiplied with the 7, and that should turn into a 6. So this is asking us, what do I multiply by 7? And it turns into a 6. So we want to think back to earlier in this week. And when we were doing our multiplication problems, to cancel a number out, we needed to have an identical number on the bottom of a fraction. So since this is a 7 and my answer doesn't have anything to do with the number 7, I'm going to put a 7 under a fraction bar. That way these two 7s will cancel out. And then if I want my final answer to be 6, I need to have a 6 somewhere over here. And so that's what number I'm going to put on top of my fraction bar. So the answer to number 45 is 6 over 7. Again, if you do 6 over 7 times 7, the 7s will cancel out, leaving us with just the 6, which is what we wanted our answer to be. So I want you to think about that and think about what the answer to number 46 should be, because number 46 says 9 times what equals, and in this one, it's n to the first power. So 9 times what equals 1? It's going to be another fraction, and the fraction is 1 over 9. Okay, so the over 9 is going to make it so that the 9s will cancel, and then the 1 will make it so that our answer is a 1. So 1 over 9 is the final answer for that one. So that's a recap of what we learned earlier in this week. A power to a power is multiplying. At this point in time, please turn to the next available page in your notes and write down today's title. For today, we are again learning one new rule, and today's rule is going to have to do with a division problem. So that is when the original question is written as a fraction. As we've been doing earlier in this week, before I tell you what the actual rule is that we're learning for today, I want to show you a visual of what it means to divide. So here I have a division problem, right? It says x to the fifth over x to the third. That means x to the fifth divided by x to the third. And earlier this week, we learned that an exponent is a counting number. So when I see x to the fifth, I can count 1, 2, 3, 4, 5 letter x's. And when I see x to the third, I can count 1, 2, 3 letter x's. Now, since these are on different sides of a fraction bar, we can cancel some out. So fraction, division, we're going to be doing canceling. We can only cancel out one for one on the top with one on the bottom. So I can cancel out 1x from the top with 1x from the bottom, 1x from the top with 1x from the bottom, 1x from the top with 1x from the bottom. And now I've run out of x's on the bottom. There are no more x's for me to cancel. So I am done canceling. Now I'm going to count how many x's I have left over. And so on the top of the fraction bar, I have 2 x's left over, or x squared. So let's think for a minute because this was a lot of writing. And again, as I said earlier in this week, totally fine if you like that visual and you want to write everything out and like physically cancel them out. That's a great way to do these problems. But there's a shortcut. And so the shortcut for today is in a division problem, when the bases are the same, the base was the letter x, you can subtract your exponents. So if we look back at the original problem, 5 minus 3 is 2. Okay, so subtraction for this. And that totally makes sense because if you think about earlier in this week, we did multiplying. And when we had a problem that was being multiplied, we used adding. So if multiplication uses adding, then it makes sense that division uses subtracting. And here's what that looks like in a generic equation. So remember that the blue sentence and the pink equation are the most important things that you're going to be writing down today. So make sure to take your time to write down the blue sentence and the pink equation. You can highlight them, you can put them in a box, you can put little stars next to them. This is the special rule we're learning today. Okay, if everybody's ready, let's do another example. So we kind of already did an example, right? 5 divided by, or x to the fifth divided by x to the third. We do 5 minus 3, and that becomes a 2. But let's try one more. Okay. So here I have another division problem. And if you're going to write down the directions, you can just write them down this one time, and then you don't need to write the directions anymore because the directions are always the same. So this one wants to know, what is the simplified form of this expression? And it's x to the 15th divided by x to the 7th. Now, don't forget, we're not actually dividing. We decided, since it's crossing things off, it's canceling, to do subtraction. So in a division problem, I'm going to take my small numbers, my exponents, and I'm going to subtract them. So I'm going to do 15 minus 7, and that will give me a final answer of x to the 8th. Division problems are subtraction problems. Now, how will this change if my larger exponent is on the bottom of the fraction? How will that be different? So I kind of don't want to do 3 minus 5. 3 minus 5 is going to be negative, and that's not very cool. So let's get that visual again. Let's see like what's actually happening. So in this problem, with an x to the third on top, I'm going to write 3-letter x's on the top. And then with an x to the fifth on the bottom, I'll write 5-letter x's on the bottom. And again, when we're canceling, we have to cancel one for one from the top with one from the bottom, until we run out on one side of the fraction. So I'm going to cancel one from the top with one from the bottom, one from the top with one from the bottom, one from the top with one from the bottom. And now at this point in time, I have run out of x's on the top of my fraction. So I can't cancel anything else. If I count my leftover x's, I do have 2 leftover x's, but they're underneath the fraction bar and they have to stay down there. They can't just like magically float to the top. We've got to keep those on the bottom of a fraction. So I'm going to end up with an x squared below a fraction bar. And since everything from the top of the fraction has canceled, I'm going to just put a 1 as a placeholder on top. So my final answer for this question is 1 over x squared. So if you notice that the larger exponent is under the fraction bar, then you want to put your subtraction problem under the fraction bar. So here's another blue sentence. So again, this is really, really important thing that we're writing down right now. If the larger number is in the denominator under the fraction bar, then put the subtraction problem also in the denominator. So you have to pay attention to what number is bigger and where is that number. Is it on the top? Is it on the bottom? Wherever the larger number is, that's where your subtraction problem will end up, and that's where your variable will end up. Your variable has to end up on whatever side had more of that letter. Make sure you wrote down the blue sentence and the pink equation. If everybody's ready, let's do one more example where the larger number is on the bottom. So as you're looking at the problem, you need to be aware of which number is larger and if it's on the top or the bottom. So in my head for this problem, I'm going to say, okay, 5 and 10. 10 is bigger than 5, and 10 is on the bottom of the fraction. So I am going to do 10 minus 5 on the bottom of the fraction. And I'm going to keep it on the bottom of the fraction. So again, it doesn't magically get to float to the top. 10 minus 5 is 5. And so my final answer to this problem is 1 over x to the fifth. Let's have you guys try a couple without my help. So at this point in time, if you could please pause the video and give every student a chance to answer these 2 problems in their notebook. And then when everybody is ready, we can check our answers together. All right, if you're listening again, that means you must be ready to check your answers. For the first one, my larger exponent is on the top, so I will expect to have just a letter y with no fraction bar for my final answer. And then don't forget that bottom letter y has an exponent of 1. So you should be doing 3 minus 1, which is y squared. We talked about this on the very first day. We said if a variable doesn't have an exponent, you can give it an exponent of 1. So we're doing 3 minus 1. Okay, on the next one, you're going to be doing 10 minus 6 under the fraction bar. So your letter D should end up under the fraction bar. 1 over D to the fourth. This is what the work would look like. Okay, it's time for our brain break. So go ahead and if you brought your deck of cards, take out your deck of cards. Today we're only using the numbers 1 through 9, so you can use an ace through 9 today. Today we're creating an equation. So you can use the numbers 1 through 9 at most once each. And then one last reminder before we pause and you try some of these problems, that if two boxes are right next to each other, that means this is a two-digit number. So remember, this is the tens place and this is the ones place. And same thing over here. So this question wants you to create a math equation where if we solved it, we would get the biggest number possible for x. When I solve this equation that you're creating, I want a huge number, biggest number you can think of, okay? So again, go ahead and pause the video and give everybody a chance to try to figure out a solution to this problem. How'd you guys do? Did you come up with an equation with a really big answer? Now, I asked my son this question. I asked him to tell me what cards he would put in here. So here are the cards that he chose. So he put the 1 and the 2 in the first two boxes, and then the 9 and the 8 in the last two boxes. And so he thinks that he has the greatest possible value. What do you guys think? Did you do the same thing? Let's think about what his x would equal. So if I were to solve this, I would minus 12 on both sides, and I would get x equals 86. Did you create an equation where x was bigger than 86? Okay. If there's time, now we do have another example. So if there's less than 20 minutes left in class, we probably can't do another brain break. But if you have more than 20 minutes left in class, let's do one more. So in this one, it's a little bit different. In this one, I want to create an equation where the answer for x is as close to 0 as possible. So I no longer want a really big answer, I actually want a pretty small answer, close to 0. So see if you can find an answer that's close to 0. Here's one that I did. Now, when I'm solving this problem, I'm going to start by subtracting my 1x. That'll give me 2x plus 8 equals 9. Then I would subtract my 8. I get 2x equals 1. And then finally, I'm going to divide by 2. And so my answer that I got was 1/2. Did you get closer to 0 than me? Can you think of maybe another equation now that you've seen what I've done? Can you think of another equation where you could get an even smaller answer than 1/2? I hope you enjoyed our brain break for today. At this point in time, go ahead and put away your deck of cards, and we need to go back to our notes for our one final example. So here is example 3. Now in this example, I made it a little bit more complicated. I threw in some coefficients, some front numbers, and there's more than one type of variable. For this problem, I'm going to treat this actually as 3 separate math problems. For my first math problem, I will be dealing with just the coefficients, what I typed in blue. So I'm just going to worry about the 4 divided by 2. For my second problem, I'm going to deal with my letter M's. And for my third and final problem, I will deal with my letter N's. So you can treat this as 3 separate problems. For your coefficients, my blue numbers, that's just like straight up normal division. This is just saying what is 4 divided by 2. Okay, so no special rules, no rules about exponents. Dividing. 4 divided by 2 is 2. Now, I wrote it still as a fraction to remind me that that 2 will belong on top of a fraction bar. So when we're done with this question, we might still have a fraction. I want to make sure I put my number 2 on the correct side of the bar. Okay, now I'm going to deal with my letter M's. Now, the letter M's have exponents, so this is where we're going to use the rules for exponents that we learned today. And today we learned that we're going to find the larger exponent, and we're going to put the subtraction problem where the larger exponent was. So for my letter M's, I will be subtracting on the bottom 5 minus 2. And so on the bottom of the fraction bar, I'm going to get an m to the third. Now we're going to start fresh when we do the letter n. So for the letter n, my larger exponent was on top of the fraction bar. So every variable might have a different place where the subtracting is happening. So this time I'm going to subtract on top 4 minus 3, and 4 minus 3 is 1. Now I just need to take those 3 parts and put them all together in a single fraction. I do need to make sure that everything stays in the same spots, and any of the ones don't need to be written down. So for my final answer, I'm going to put this 2 on top. This m to the third will stay underneath. And this n to the first, which is just the letter n, is going to go on top as well with the number 2 that was already up there. And so my final answer for this problem is 2n over m to the third. When you're ready, let's try these 2 all on your own. So see if you can get the right answer. Go ahead and pause the video. And when all of the students are ready to check an answer, you can restart and we'll see how we did. All right. How do you think you guys did? Did we do good? Let's check. On that first fraction, my final answer that I got is 5x to the 5th over y to the 3rd. So let me explain how I got that. First, I started with 10 over 2. And that just means what's 10 divided by 2. And that's where the 5 came from. 10 divided by 2 is 5. For my x's, and now we're dealing with exponents. So now we're going to use the rules for exponents. For my x's, there's an invisible 1 down here. So for my subtracting problem, I did 6 minus 1, and that's why it turned into x to the 5th. And then for my y's, I did 5 minus 2 on the bottom, because that's where the bigger number was, and that's where I got my y to the 3rd. All right, let's check the next one. So for the next one, I got 1 over 4a squared. Now, the 4 is on the bottom because when we have this fraction right here, 2 over 8, the larger number's on the bottom. So that's kind of the same as with exponents. If you're doing a division problem and the larger number is on the bottom, then your final answer is going to end up with the number on the bottom. You want to think of this like simplifying. I can divide both of these by 2. 2 divided by 2 is 1, and 8 divided by 2 is 4. For my a's, I subtracted on the bottom, so 5 minus 3 is a squared. And then for my B's, I had the exact same thing on the top and the bottom. It was B to the seventh and B to the seventh. So if we think visually again, all 7 of the B's are going to be able to cancel. That just means that there's going to be no more B's. They're all gone, right? This cancels with that only because it's exactly the same. Now, if you did subtracting, 7 minus 7 is 0, which also means that there's going to be 0 letter B's left over. So that's why the letter B did not make it into our final answer. All right, guys, we did it. We made it through the whole lesson. Now, for your homework today, I don't have problems from the textbook. So instead, we made a worksheet. So at this point in time, if you could please hand out tonight's worksheet, 7-4. And if there's more time in class, you guys can use the rest of the class period to work on this worksheet. And I will see you guys next week on when we meet in person again.